Hello everyone, welcome back to my channel. Today we will be talking about an important topic, number system. When I say number system, it is the way we use numbers in our daily lives. When I say daily lives, in human life we use number system decimal. When it comes to working on laptops somewhere, we use number system as binary because machine somewhere only understands two digits, zeros and ones. In the family of binary, we further have two more number systems, octal number system and hexadecimal number system. When I say octal and hexadecimal, somewhere they are also using 0 and 1 for representing their numbers. First we will start with decimal number system. Decimal number system, numbers used in this number system are 0 to 9. Somewhere total 10 digits are there. That is why it is called base 10. Binary number system only uses 2 bits, 0 and 1. That is why it is called as base 2. Octal number system, it is using 3 bits to represent the binary data. If I say 3 bits, 2 raised to power 3, 8 possible combinations are there, and when we start using binary, numbers will be what? 0, 1, 2, 3, 4, 5, 6, 7. That means somewhere base of octal number system is what? 8. Then comes hexadecimal. Hexadecimal is base 16. It uses 4 bits to represent a number. 4 bits means 2 raised to power 4, 16. Directly 0 to 9 will be there. After that, because 1011 there are 2 digits, for 10 we use A, for 11 we use B, for 12 we use C, 13 D, 14 E, 15 F. So somewhere in hexadecimal, numbers used are 0 to 9 and A to F, total 16. That means it is what? Base 16. We'll first start with the basic, that is conversions of decimal number to a binary number. Decimal number system base 10, binary number system base 2. Let us take a simple example that we want to represent decimal 16 into its binary equivalent. Whenever you are converting decimal to any number system, you will always divide, and in this case we will divide by 2. So while dividing by 2, the remainder is kept on this side and the answer or the quotient is written under the number. So further we'll again divide. Again it can be divided. Division will continue till you get a number as remain your quotient less than the divisor. So this is further, it cannot be divided. Now the last bit is your MSB. The first bit is your LSB. So this is the binary representation of 16. Let us have one more conversion. Let us say we want to convert this decimal number system into its equivalent binary. Now, while we are solving these questions, kindly note that this question has 2 parts, one integer, another fractional. For integer, we will be using the same rule, that is divide by 2. But for fractional part, we will be multiplying, and again multiplication will be done with 2 only. So taking up them separately, 182 divided by 2, writing the remainder on one side. We will continue to divide till we get the value as the value less than the dividend. Somewhere this is the binary value. Now I pick up the fractional part. We will be multiplying the fractional part by 2, and while multiplying, whatever comes as integer will be kept separately, and the fractional part will be again used for multiplication. Again using the fractional part. And you will continue this till you are having either 0 in the fractional part, or if you are not getting 0, you will continue for bare minimum 4 values. And then you will take the numbers from this side. So somewhere, if I need to write the number, it will be dot 1010. Now we'll start with binary to decimal conversion. If you remember, from decimal to binary we did divide. So from binary to decimal we will do multiply. And we'll multiply with what? We'll multiply with 2. Let us take one example. Now if you observe, this is a mixed binary number and I need to find its decimal equivalent. How to do it? While doing it, you will keep in part that this is integer. Other part is fractional. Both will be multiplied by 2, but the powers will vary. Let us start solving it. You will multiply every binary digit with a 2. And multiplication will be similar before the dot as well as after the dot. Now, to be kept in mind is that we have a dot here. Before this dot, numbers will be 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. What I mean to say is, before this dot, your numbering will be positive starting from 0. After this, numbering will be in negative scale. Now, 2 raised to power 4, 16. Multiplied by 1, answer is 16. 2 raised to power 3, 8. Multiplied by 0, answer is 0. 2 raised to power 2, 4. Multiplied by 0, answer is 0. 2 raised to power 1, 2. Multiplied by 1, answer is 2. 2 raised to power 0 is 1. multiplied by 1, answer is 1 dot. Now on the other side, first is 1 by 2 multiplied by 0, but because it is being multiplied by 0, answer is 0, plus 1 by 4 plus 1 by 8. Then 16 plus 2 makes 18 plus 1, 19. Talk about the other half. 0 plus 0.25 plus 0.125. If you add them up, it comes out to be 0.375. And this is the decimal equivalent of the given number. Now we'll start with octal number system. When I say octal number system, it uses 3 binary bits to represent one decimal number. Let us say 1, we'll represent it using 001, 2, 010. Similarly, 4 will be represented as 100. Similarly, 7 will be represented as 111. 0 will be represented as all zeros. 2 raised to power 3, 8 possible combinations are there. That is from 0 to 7. 0 to 7 decimal numbers can be used as octal numbers, where you can use 3-bit binary representation as shown. Now, let us start with the conversion. First conversion, decimal to octal. Decimal to octal, D for decimal, D for divide. So let us consider the number 239. 239 needs to be converted from decimal to octal. D for decimal, D for divide, divide by what factor? Divide by 8. So when we'll divide 239, we get remainder as 7. When you further divide it, you get the value as 357 to the base 8. Let us have opposite conversion, that is octal to decimal. While this, we will multiply with factor 8. Let us take the same number 357 to the base 8 to decimal. We'll multiply every octal digit with 8 and then give powers to 0, 8 starting from LSB. Somewhere this will give you 7, this will give you 40, and this will give you 192. When we add all of them, 192 plus 40 makes 232 plus 7 makes 239. Somewhere we have converted octal back to the decimal. So again, quickly recapitulating, if you are converting decimal to octal, you need to divide by 8. If you are converting octal to decimal, you need to convert or multiply by 8. Now, one more way in which the same question can be asked is that convert 375 to binary. That is 375 to the base 8 to 375 should be converted to an equivalent binary. In this very case, what you will do, you will represent every octal digit in 3 bits. How do we write 3? 011. How do we write 7? 111. How do we write 5? We write it as 101. So the conversion is what? To the base 2. So somewhere this conversion can also be easily done. Next type of number system is what? Hexadecimal. Hexadecimal means it is going to use 4 binary bits 4 binary bits means 2 raised to power 4, 16 possible combinations are there. Starting from 0 to 9, we'll be using 4 bits. Ten will be represented as A, 11, 12, 13, 14, 15, B, C, D, E, F. So in totality, there are 0 to 15, 16 numbers. They'll be using 4 bits to represent the number. When I say 4 bits, somewhere 2 raised to power 4, 16 possible combinations are there. 4-bit representation of 0 will be 0, 0, 0, 0. 1 will be 0, 0, 1, 1. And so on. Now, let's start with the conversion factor. 2 types of conversion can be done. Decimal to hexadecimal. D for decimal, D for divide. Hexadecimal, in this very case, divide by 16. Let's start with the very first conversion. Taking number 356 and we are going to convert it into hexadecimal. So we'll be dividing by 16 somewhere. So what is the number? Number is 164 to the base 16. Similarly, if I want to convert hexadecimal to decimal, what will I do? I'll multiply by 16. I hope you can solve similar examples like this. That's all for today. We have talked about broadly all types of number system. When I say all types of number system, we talked about decimal. Decimal means base 10. We talked about binary. Binary means base 2. We talked about octal. Octal means base 8. We talked about hexadecimal, which means base 16. Whenever the conversion factor is from decimal to any of the number system, that is D for decimal, D for divide. Somewhere whenever it is decimal to binary, decimal to octal, decimal to hexa, you will always divide by 2, 8 and 16 respectively. Other way round, if you are being given hexadecimal to decimal, you will multiply by 16. Octal to decimal, you will multiply by 8. Binary to decimal, you will multiply by 2. And if you are being asked between binary, octal and hexa, what you will work on? You will only work on arrangement of binary bits. In case of arrangement, if it is a binary, you will start pairing it in 3 bits. If it is binary to hexa, you will start clubbing it as 4 bits and so on. I'll soon be coming with new videos. That's all for today.